Once the detector is connected, parameter configuration and data sampling can be carried out using the SIBDM server software. Based on your application needs, you can choose the network adapter or serial port as the setup interface. In either mode, the SIBDM server can detect a connected BDM and display its ID. Basic information like the BDM firmware version, ID, and max bin value can be viewed on this page. Network information includes the BDM source IP and port as well as the destination IP and port. On the threshold page, you can globally define a set of threshold values for all 72 channels in one BDM, or check and edit a specific threshold for a specified channel. Data acquisition can be performed on the Gather page. There are 3 modes to choose from: acquisition in preset durations, acquisition of preset singles, and manual mode. SIBDM server collects and subsequently converts raw data to processable data. However, the conversion process increases resource costs and reduces the sampling rate. Use the normal process mode when the source rate is lower than 500 kilocounts per second and the high-speed process mode when the source rate is higher than 500 kilocounts per second. Once you've selected the acquisition mode, click the Start button to begin data collection. You can terminate the process at any time by clicking the Stop button at the bottom of the page. After the process is completed, the status bar displays the sampling time, sampling rate, sampling amount, and data source distribution. Data files are in binary format and consist of small units, each of which include information on a single event. One unit contains 64 bytes. The first byte is an unsigned char that represents the channel number of the single event. This is followed by 8 doubles, which contain 8 bytes each. These represent the 8 MVT times in the single event. Based on the 8 MVT time values and their corresponding thresholds, an MVT sampling profile can be plotted. Combined with the scintillation pulse mode, you can recover the original pulse and obtain energy and timing information. This information can be further analyzed using software for coincidence discrimination and imaging reconstruction to create the final reconstructed image.